Welcome back to the Deep Dive. This is week 2 of the 2026 series, and we are presented by Bluewater Auto Restoration.
It's good to be back.
If you're just tuning in, just a reminder that new Deep Dives are released every Saturday morning. We try to cover topics designed to get you smart, fast, on things you might be really curious about.
And today's topic is one that hits close to home for a lot of people.
It really does.
Yeah.
Today's Deep Dive is, well, it's for anyone who wants to understand the brutal, ground-level realities behind a classic car restoration budget.
Brutal is the right word.
Yeah, we're trying to strip away the veneer of those glossy, super highly edited reveal videos you see everywhere online.
The ones where a car rolls out of a garage in 5 minutes of video time.
Exactly. And instead, we're going to dive deep into the technical, the labor-intensive, and of course the financial decisions that actually determine if a project succeeds or, well, more often than not, if it fails. So the topic today: budgeting a restoration. Reality versus YouTube fantasy. Our mission here is to figure out exactly why restoration costs just spiral out of control. We're going to focus really relentlessly on that fundamental conflict between two goals: making a car look stunning and making a car that will actually last.
And those two things are often fighting each other for every dollar in the budget. This stuff isn't just for someone thinking about a project, It's really crucial for understanding the engineering logic behind preserving any historic vehicle. We see it all the time. A restoration is, by its very definition, an unknown condition project. And budgets fail, consistently fail, not because of bad luck.
Yeah.
It's because the assumptions you make at the start about the car's condition, they were treated as technical facts, and they just weren't.
So we're here to break down that technical architecture, the unseen structure that really dictates the cost, and how you have to plan for it before you even touch the car.
Before you turn a single wrench.
Okay, let's unpack this right away then. Because to budget this thing properly, we have to completely reset the definition of a starting budget.
We do.
Most people, and this is a deep psychological thing in finance, right? They anchor themselves to totally the wrong number. And that financial anchor, it can just poison the project's future before a single tool comes out of the box.
So what's that anchor? What's that number that people fixate on?
It's almost always the purchase price of the car.
Every time.
You buy the dusty shell, the rolling chassis, the barn find, maybe even a project that's already running, and that price, whatever it is, that becomes your mental baseline. You think, okay, I spent 15 grand on the car, so I should be able to spend, maybe 30 grand to restore it.
And that, based on everything we see, that right there is the trap. That purchase price is, and I'm quoting here, almost always the wrong place to start. It's just a profoundly misleading point of reference.
I get that it's just the cost of entry, but can you explain why it's so toxic to the rest of the budget?
Well, it's because it implies some kind of parity. It suggests the value you just paid for is somehow connected to the total effort required to finish it.
Right, like they should be in the same ballpark.
Exactly. But that purchase price is just the cost of admission. That's all it is. It gets you into the game, but it tells you nothing, absolutely nothing about the complexity, the labor, or the material costs you're going to need to actually finish.
So the real budget starts later.
The real budget technically begins the moment that car is on your property, unloaded, and evaluated. And crucially, evaluated in real, disassembled conditions. Not just from the photos or what the seller hopefully told you.
So as soon as the car is sitting there, we run right into the defining nature of restoration itself, which is that these are inherently unknown condition projects.
Precisely. And if you just pause and think about the technical implication of that statement, the sheer uncertainty of it, that defines the entire project's risk. Well, if the car's full condition, its structure, all the rust, its mechanical and electrical health, if all that were completely known down to the last weak spot weld, it wouldn't be a restoration candidate.
It would just be a repair job?
It'd just be a scheduled repair. You'd have a list and you'd tick the boxes.
So the defining thing about a restoration is the uncertainty, which means every number you come up with before you've taken it completely apart it's just a guess.
Is. Absolutely. Until that vehicle is stripped down to nothing, bare metal, and the shell is properly mounted on a body jig, every financial number you create is operating on pure assumption, not hard facts.
And assumptions in this world are always hiding problems. Financial liabilities.
It's a perfect structure for hiding liabilities. The car is literally a container designed to look better than it is.
So let's talk about how those liabilities are hidden. because they are literally engineered to disappear.
Well, paint is a fantastic masker, for starters. It hides surface rust, old Bondo patches, shoddy repairs. You don't see any of it until you start stripping it.
And what about undercoating? That was supposed to protect the car, right?
Ironically, yeah. Decades-old undercoating becomes a huge budget liability. It hides compromised repairs, it traps moisture underneath, and you see no outward sign of the rot happening beneath it.
And the interior, I mean, a seemingly solid interior can feel fine, but that's often just a cover.
Oh, absolutely. Interior panels, carpets, they are notorious for hiding structural problems. Those door panels that look okay, the rear trim, they can be hiding severe rust in the sheet metal, compromised bracing, even rusted out body mounts.
And you only find that when you pull them off.
You only find it when you lift them up, and by then, the clock on expensive disassembly labor has already started. So the key takeaway for anyone trying to budget is this. Every restoration budget that fails because those initial hopeful assumptions were mistaken for hard technical facts.
The starting line isn't the price you paid.
No. The starting line is the moment you stop assuming and you start documenting the reality of what's actually there.
That clarity, that technical truth you find after taking it apart, that leads us perfectly into the next huge budget driver, which is you have to decide what you're actually going to do with the car once it's done.
Yes. If we connect this starting point, the reality of the car's condition, to the project's bigger picture, the single most critical factor that drives the final cost is what we call clarity of intent.
And this isn't some philosophical question about what kind of owner you want to be.
Not at all. This is a technical requirement. Because the intended use of that vehicle, it dictates every single engineering constraint, every material you choose, and every labor hour that follows.
So if you don't define your intent up front, you get conflict, you get expensive rework, and that's what a budget just can't survive.
That's it. You have to decide right at the start, are we building this for static display or are we building it for regular long-term use?
The show car versus the driver.
Exactly. And that distinction creates a fundamental technical split. The resources, the type of labor, the parts cost, the whole expense profile is completely different for each one.
And mixing them midstream is
financial suicide.
Let's break down that split. For a show car, the priority is visible perfection. It has to look flawless.
Exactly right. A show car is meant to be judged, so its engineering focus is all on finish quality, panel gaps, paint depth, immaculate detailing in areas you can see. It just needs to tolerate being gently rolled into a trailer and sitting under some lights.
The operational stress is basically zero.
Minimal. But a car built for regular use, the driver, that machine has to tolerate stress on a completely different level.
What kind of stress are we talking about?
We're talking about constant heat cycles in the engine bay, dealing with those extreme temperature swings over and over. It has to handle modern traffic, which means sitting there, idling, with very little airflow.
Things it was never designed for.
Never. It has to withstand the dynamic loads, the vibration, the road debris from extended use on all kinds of roads. The whole structure has to handle loads that a car sitting on a velvet rope will never, ever experience.
So for a driver, you're prioritizing all the invisible stuff, the infrastructure that judges will never see.
That is the essential trade-off. It's the prioritization of resources. A show car's budget goes to the finish and the cosmetics. A driver's budget must go to the invisible systems that ensure it will last. Like robust heat management, systems that are actually serviceable on the side of the road, reinforced suspension parts, and just the overall structural robustness to handle years of being driven.
So that choice, show versus driver, it really is the choice between building for operation right now versus building for longevity over the next 20 years.
That's a great way to put it. If you haven't engineered for longevity, the system will fail under sustained use, and that leads to the dreaded, cost-intensive rework we're all trying to avoid.
And that rework is the cost of trying to add longevity back in after the fact.
Yes, you have to budget for the complete teardown of systems that might seem like they work now, because they won't work reliably later. You have to budget for a complex electrical system design, not just pulling some wires, because a short on the highway is a catastrophe.
Right.
Longevity means spending money on what you absolutely do not see.
I think the best way to illustrate the risk here of mixing these intents is that analogy of the movie set versus the home.
It is a perfect technical analogy because it gets right to the heart of structural reality versus cosmetic appearance. Just compare building something for a movie set versus building a residential home.
From the street, they can look identical. The facade, the windows, the paint, it's all the same. The cosmetics are perfect.
But the movie set is built purely for display. It uses minimal support. It's drywall instead of load-bearing timbers. It just needs to stand up for a few lengths and look good on camera. It's structurally thin. It's disposable.
The home, on the other hand, is built for reliability. For longevity, it requires all this heavy, invisible infrastructure.
A proper foundation, load-bearing walls, plumbing that won't leak under pressure, insulation to handle heat cycles. You invest 80% of the cost in things your eye will never, ever see.
Okay, so here's the financial fallout for a car restoration. A project starts out focused on cosmetics, building a magnificent movie set car. But then, halfway through, the owner decides, you know what, I actually want to drive this thing every weekend.
They shift the intent toward reliability.
And you can't just flip a switch.
No. The engineering reality is that the builder now has to tear down the walls, peel back all that cosmetic perfection, and install the invisible infrastructure that was skipped. The storm-proof foundation, the robust plumbing.
Things that were never in the movie set plan.
Never. And this causes massive unbudgeted cost overruns and technical rework because you're retrofitting longevity into a structure that was only designed for looks.
Can you give a specific car example?
Sure. You installed a beautiful thin dashboard on some light clips because it was just for show. Now, for road use, you have to rip it all out to install proper vibration isolation and a fire barrier. The failure to define that intent up front leads to these conflicting decisions that They create a vehicle that's expensive, compromised in both looks and reliability, and probably ends up unfinished.
Okay, this is where we get from the high-level theory down to the shop floor. Because reliability, as you said, means spending money on parts and labor that give you zero visual return. This is exactly where that YouTube fantasy that you can do a world-class job for cheap just completely falls apart. Because these costs are often the biggest drivers in the budget, but they're invisible on screen.
And they are non-negotiable if you want the car to last.
So let's start with the one that scares every experienced restorer because it's the #1 budget accelerator, metalwork.
Metalwork holds that title because of one crucial fact of physics. Rust is systemic. It's not an isolated patch. It's an organic process that migrates along very specific pathways.
So when a novice looks at a rusty spot on a quarter panel, they might see a little hole they can patch. What does a restorer see?
A restorer sees a compromised system. They see the migration path. Corrosion moves relentlessly through seams, overlaps, spot welds, especially through those moisture traps and box sections that were engineered into the car from the factory.
So that little rust patch means?
It means the internal bracing, the sail panel support, the wheelhouse structure, they're almost certainly compromised too.
So finding that one visible spot of rust triggers what you call a massive ripple effect of discovery. And that means an exponential jump in labor hours.
Absolutely. The structural integrity is all interconnected. Finding rust in a simple floor pan often means you're also dealing with compromised frame bracing underneath it, weakened rocker structures, which support the whole body,
Wow.
damaged body mounts, and critically shifted alignment reference points for your suspension. All of those hidden parts have to be sound or the car will never drive straight, handle right, or it might just flex itself apart over time.
Which leads to the technical issue of sequencing. You can't just cut out the bad piece and weld in a new one.
No, and that's where the high labor costs come from. It's mandatory. Metal repair requires a highly specific sequence, which means labor hours and time on a specialized jig. For instance, if you replace the outer fender skin before you repair the inner fender structure,
You're in trouble.
you've lost your crucial reference points, the ones that dictate suspension alignment and how the hood and door will eventually fit.
Can you walk us through an example of how one mistake in that sequence can just ruin a project's dimensions?
Sure. Let's say you just replace an inner rocker panel, and then you weld the new outer rocker on without making sure the door post is secured and braced to a frame jig.
Okay.
You risk dimensional collapse, the whole thing can sag. So later, when you try to hang the door, it won't fit. The gaps will be a mess. You might have accidentally twisted the entire chassis by just a millimeter or two.
Which doesn't sound like much.
But it's enough to completely compromise your suspension geometry and cause alignment problems that you can never, ever truly fix without starting all over again.
So that sequence is everything. Inner structure first, then bracing, then the outer cosmetic stuff last.
It has to be that way. You're not just welding metal, you're restoring structural geometry.
All right, moving on to the mechanicals. We run into what you call the running fallacy. This is that profoundly optimistic and budget-killing assumption that an engine that starts and idles is a good serviceable engine.
It is the most common and most expensive budget error because operation does not equal serviceability. It definitely doesn't equal longevity.
So if you do a compression test and the numbers look okay, why is a full teardown still a non-negotiable budget item for a car you intend to drive?
Because compression tells you just a fraction of the story. We're talking about internal degradation that's hidden deep inside the block, and it only shows up under load, not at idle.
What kind of degradation?
Things like the subtle loss of tension in piston rings, worn valve guides that let oil seep through, sludge building up in critical oil passages, micro-pitting on bearing surfaces.
You'd never see.
Never. These parts degrade over time from acidic residue, lack of use, and when you suddenly introduce regular heat and load, those degraded parts will fail fast and potentially catastrophically, which means you're paying twice as much to fix it later.
And it's not just the block. The fuel systems are a liability just based on chemistry, right? Even if the car's just been sitting.
Absolutely. Modern gasoline, especially with ethanol, it's chemically corrosive. Over time, that causes internal corrosion in carburetors, fuel pumps.
And the tank itself.
Fuel tanks, if they sit, collect moisture, they rust from the inside out, shedding all this particulate matter that clogs everything up. And the fuel lines themselves, they degrade from the inside out. For reliability, you need a complete overhaul. New lines, clean tank, rebuilt carb. Not just a quick cleanup.
Okay, let's talk heat management. This is where vintage design hits modern reality and just fails. Classic cooling systems were famously marginal, even when they were new.
And that marginality is catastrophically exposed by modern driving. Classic cars were designed for open roads, driving at speed, which pushes a lot of air across the radiator.
We don't drive like that anymore.
Now we face long, extended idling and traffic jams, conditions they were never engineered for. This creates sustained high heat situations that expose every single weakness in that original cooling system.
So what specific budget items does that mean you need?
It means you have to invest in modern heat management. Upgrading from a 2-row copper radiator to a bigger aluminum 3 or 4 core unit. You have to calculate the right fan size, put in a proper shroud to pull air at low speed.
And the water pump.
You have to replace the 50-year-old water pump. If you skip this, say, $2,000 to $4,000 upgrade, you're risking overheating, blown head gaskets, cracked blocks, a $10,000 plus repair later on.
Moving on to the drivetrain. The transmission and the differential. These are the ultimate invisible systems. They're bolted up, out of sight, out of mind, and they're often huge, underestimated cost centers. Why do they hide their failures so well?
Because they're hidden where, it just doesn't announce itself until you put a sustained, significant load on it. At low speeds or on a short test drive, the chassis can mask severe internal wear.
So what's happening inside a differential that leads to these high hidden costs?
We're talking about parts under massive stress, gear tooth wear, which shows up as pitting, backlash issues, the clearance between the gear teeth, the condition of the synchronizers in a manual trans, differential carrier fatigue.
And these might just be a little whine at low speed.
A minor whine or a clunk, yeah. But they become huge liabilities under sustained highway use or the shock of a hard launch.
And setting these things up correctly is what drives the labor cost, isn't it?
Precisely. A differential is a system of microtolerances. Setting the backlash and bearing preload correctly requires special tools, meticulous measurement, real skill. If you skip the necessary teardown and correction, which is expensive labor, you just can't get longevity.
So that rear end that was quiet on the test drive can just grenade itself the first time you take it on the highway for an hour.
That's the reality. And replacing a differential that has failed under load, that's a budget hit that can run into 5 figures and just stop a project cold. Especially if that money was already spent on shiny paint.
It all comes back to that. If longevity is the goal, the invisible systems have to be budgeted for early.
Has to be.
Finally, let's hit electrical systems. Maybe the most underestimated cost center of all. Not because the wire is expensive, but because the labor to fix them it's a black hole.
It is. Electrical failure is a complexity that just escalates over decades. The original wiring looms, they weren't designed to last 60 years. The insulation degrades, gets brittle, and that introduces intermittent faults. The dreaded, it works sometimes, but not when it's hot out problem. That requires massive, tedious diagnostic hours to trace down.
And then you have to deal with these 60 years of previous owners.
And that's where it becomes exponential and potentially lethal. Every owner adds their own layer of complexity. Every splice, every bypass, every poorly installed radio, It all increases resistance, creates voltage drop, and adds more failure points.
Usually with household wire nuts.
Or just twisted and taped, a huge fire risk. You're dealing with a chain of undocumented, compromised engineering that you have to completely undo.
So you can't just fix the one bad wire. A proper rewire is a full system redesign.
It has to be. Rewiring properly isn't just replacing old wire with new wire, it's technical circuit design. It requires careful load calculation, especially if you're adding modern accessories.
Like power windows or a big stereo.
Exactly. It demands a really effective grounding strategy to get rid of those stray voltage problems and robust protection planning using modern fuses, relays, and circuit breakers.
Why are relays so important in a classic car budget?
Relays take the high current load off the original, thin wiring, and the brittle old switches. Your headlights, horn, fuel pump, they should all run off heavy-duty relays. Budgeting for this modern upgrade is non-negotiable for safety and reliability, but it's completely invisible once the dash is back in.
And that design work takes a ton of time.
It can be 80 to 120 hours of pure labor. That translates directly to high cost for a result that no one will ever see.
Okay, this is where we move from what the costs are to why they spiral out of control. So what happens when that drive for visual perfection collides with the need for mechanical robustness?
The conflict there drives financial decisions through a really predictable and destructive mechanism. We call it perceptual escalation.
That sounds like an emotional reaction, but you're framing it as something technical and inevitable.
It is. The definition is simple. It's when significant improvements in one area force you to make unplanned spending in the areas around it. And it's perceptual and inevitable because once you raise the quality bar in one system, let's say you get a mirror-like paint finish, your brain's perception of what is acceptable in the next unrestored system just drops dramatically.
The imbalance becomes glaring.
Glaringly obvious. It's the cosmetic domino effect. You set a new standard, and everything that used to be okay now looks shockingly inadequate by comparison.
Which forces you to divert resources you didn't plan on spending.
Exactly. Let's use a real example. An owner invests $15,000 in a flawless, multi-stage paint job. Perfect paint, perfect gaps. Now the car looks perfect. Suddenly, the $500 he budgeted to just clean the chrome bumpers feels totally insufficient because the slight pitting on that original chrome looks terrible next to the flawless paint.
So now he's forced to spend $2,500 on getting them fully replated.
And the domino falls again. Now the paint is perfect, the chrome is new, and he opens the hood.
And the engine bay looks terrible.
The unrestored engine bay, with its grimy wiring, slight oil leaks, and faded finishes, it looks miserably poor compared to the perfect fenders right next to it. So now, driven by that escalated perception, he's psychologically forced to divert funds to detailing the engine bay, powder coating parts, things that were never in the plan.
The vehicle itself is now dictating the spending priorities, not the original spreadsheet.
That's it. Which brings us back to that house renovation analogy. It perfectly illustrates this conflict between the visible and the structural.
Right. If you spend your limited budget on a luxury kitchen, the cosmetics, the cracked foundation underneath, the reliability becomes a massive liability that threatens the whole investment.
And if you fix the foundation first, you might not have money left for the fancy kitchen, leaving the house sound but unappealing.
But the escalation is the real killer. The foundation is fixed, the kitchen is gorgeous, and the second that luxury kitchen goes in, suddenly the living room next to it, with its peeling wallpaper, looks absolutely unacceptable.
That is perceptual escalation in action. It forces unplanned spending just to match the standard you've already set next door. In a car, this happens a lot with the interior.
How so?
You might ignore the worn-out seat frames and collapsed springs to save money, but then you find that when you sit inside a car with the perfect exterior and a high-end dashboard, the compromised feel of those seats becomes intolerable.
It just doesn't feel right.
It doesn't. And that's why interior restoration, which seems cosmetic, involves critical structural costs that are often ignored. Seat frames get tired, springs collapse, foam degrades. Ignoring that results in a car that looks good but feels cheap. And the owner always spends the money later at a higher cost to correct that tactile experience.
Speaking of cosmetics, paint and finish work are so misrepresented online because all the labor is invisible until that final coat goes on.
Yes.
And the pressure to make the car look good on a budget often leads to cutting corners right there on the prep labor.
And that is the ultimate financial irony in restoration. The cost of the paint itself is trivial compared to the labor. The majority of paint costs are incurred during preparation.
All the sanding?
The surface correction, the intensive block work to get panels perfectly flat, straightening panels, applying primer systems, guide coats, all of that happens before a drop of color is even mixed.
And that tedious, low, expensive work is what dictates the quality and longevity of the finish. So if you rush it,
you set the rework trap. Owners or budget shops try to shave labor hours off prep. You rush the sanding, you don't remove old contamination, you rush primer drying time, you get solvent pop later.
the flaws show up months later.
Months or even years later. And rework is always more expensive than doing it correctly the first time because you have to strip back all the bad work, sometimes just the color coat, sometimes all the way back to bare metal before you can even start over.
So that decision to save money on prep is a financial choice that almost guarantees you'll spend way more later. You're paying twice. You paid for the shortcut that failed, and then you pay for the proper, meticulous procedure that should have been done in the first place.
And that applies to more than just paint.
Oh yeah. It's true for a rust repair. Patching rust is a cosmetic shortcut. Replacing the entire compromised panel and structure, that's longevity. One looks good for a year, the other lasts for decades.
Beyond the labor, we have to talk about just getting the parts. Availability and compatibility. This is another one of those technical factors that doesn't make it into the glossy summary, but it can blow up your timeline.
Parts are a massive time sink, and so they're a labor cost sink.
Yeah.
Even if you have the money, just finding the right parts and making them work creates a huge labor expense that has to be in the budget.
Let's talk about reproduction parts. They seem like the easy answer, but they come with their own baggage.
They do. Reproduction parts are a huge variable. They vary widely in quality and, most critically, in dimensional accuracy.
So the new fender doesn't just bolt on. You might buy a brand new body panel, only to find it doesn't align correctly, the bolt holes are off, or it needs significant manipulation, hammering, cutting, welding to get the fitment and panel gaps right.
And that's all unbudgeted labor.
That $800 panel can easily require $1,500 of unexpected skilled labor just to make it fit.
And if you go for original parts instead, the cost dynamic shifts, again, from modification labor to restoration labor.
It does. Original parts, if you can even find them, might be dimensionally perfect, but they're old. They need to be restored themselves. New plating, new wiring, new seals.
So you're paying twice.
You incur the cost to acquire the rare part, and then you incur significant labor costs to restore it before you can even install it. That double cost acquisition plus restoration labor has to be meticulously accounted for.
It sounds like the parts are rarely the problem. It's the labor to make them fit a decades-old, non-uniform car.
That's the engineering truth. Modern manufacturing standards just don't perfectly align with mid-century standards. Every classic car is slightly different, and reproduction parts just add another layer of variance. The budget has to reflect the skilled time required to bridge that gap.
Okay, so after this deep dive into all the ways a budget can just get blown up, the rust, the chemicals, the electrical complexity, perceptual escalation, what does this all mean for someone trying to create a viable budget? It sounds like we can't eliminate surprises, but we need strategies to survive them.
That's it, exactly.
Let's circle back to the biggest variable of all time. Time breaks more budgets than metal or parts ever could.
Time is the single largest and least predictable factor in any restoration. Projects expand constantly, and not just because of the technical discoveries, the rust you find.
Right.
Projects expand because the owner's standards evolve as the work progresses. That perceptual escalation we talked about guarantees the owner will want more time spent on areas they previously ignored, and that just consumes labor hours and money.
So the budget has to anticipate not only the unknown condition of the car, but the unknown evolution of the owner's own standards.
Yes, which is why contingency is so vital. But it needs to be defined technically, not just as a slush fund.
What do you mean by that?
A realistic budget must include contingency planning. But from a technical standpoint, a contingency isn't just a buffer, a bit of extra cash. It is a built-in acknowledgement of uncertainty. It's part of the engineering plan.
How much contingency do you need to acknowledge that much uncertainty?
Depending on the car, you're often looking at a contingency of between 20 and 40% of your initial labor estimate. You're dealing with vehicles that weren't built to modern tolerances and have aged in totally non-uniform ways.
And that allowance is what lets you survive the big discoveries.
It's what lets you absorb finding terminal frame rust or hidden collision damage without forcing you to make compromises mid-build, like using cheap parts or rushing paint prep. Or worse, abandoning the project because you're out of money.
So the ultimate goal isn't to create a perfect spreadsheet with exact numbers down to the dollar, which we've established is impossible anyway.
No, budgeting correctly doesn't require predicting the exact final number. It requires understanding where the uncertainty lives in the metal, the electrical, the drivetrain. It's knowing where the labor concentrates, paint prep, diagnostics, parts modification.
And knowing where compromises will have long-term consequences.
Exactly. Ignoring structural or reliability components for the sake of cosmetics. The goal is not to eliminate surprises. That's a fantasy. The goal is to have the financial resources and the technical plan to survive them without compromising your original intent.
And that clarity of intent driver versus show has to come before any estimate, or the whole spreadsheet is worthless.
It is fundamental. If you define the intent, you define the technical constraints. If the constraint is longevity and reliability, a driver, you prioritize the upfront cost of dealing with heat management, structural integrity, serviceability.
You pay more now to save a lot more later.
You pay a premium now to save triple that amount later in avoided rework.
Which means a restoration that actually finishes, one that gets to the road or the show field the way the owner wanted, it's not the one that started with the lowest estimate.
Never. It's the one that respected the engineering reality and the financial uncertainty from the very beginning. It's the project that allocated serious resources to all that invisible infrastructure needed for longevity.
That's a profound takeaway. What really stands out to me after this dive is that budgeting a restoration is fundamentally an engineering task. It's not just an accounting task.
Not at all.
You have to define the technical requirements, driver versus show, before you even think about turning the first wrench.
Absolutely. The decision about the budget is a technical and financial choice between building for operation and building for longevity. A choice that has to prioritize that upfront investment in the invisible stuff to reduce the far more expensive rework later on.
If you prioritize building the movie set.
Then you have to be prepared to accept that the foundation will fail under sustained use.
So we've established that this clarity of intent is a technical requirement for success. What's the final provocative thought you want to leave our listener with today?
Well, consider this. If the running fallacy is so common, this idea that a running engine is automatically a serviceable one, then how do you truly value a classic car today without fully accounting for all of its invisible liabilities?
The things that dictate longevity.
The drivetrain, the electrical systems, the structural integrity related to heat management, that massive unquantified gap between the perceived value of a car and the actual investment required to make it reliable. That gap is the fantasy, and it's the greatest risk to every buyer.
That leaves us with a lot to think about, especially for anyone looking at a project vehicle this year. Thank you for diving deep with us into the reality of restoration budgeting.
My pleasure.
Just a reminder, this deep dive was proudly presented by Bluewater Auto Restoration, your trusted partner in navigating the complexities of classic vehicle renewal. We really encourage you to visit the Bluewater Auto Restoration website for more information on their expertise and services. That's bluewaterautorestoration.com.
It's worth a look.
You can find the deep dive every Saturday morning on Spotify, Google Music, YouTube, Apple Podcasts, Amazon Music, or SoundCloud. We'll talk to you next time.